This structure is so massive, it shifted the distribution of water on Earth, slowing the planet's rotation by a fraction of a microsecond. The construction of this barrier dictated a total reorganization of the river's mechanics, directing exactly where the water flows and settles across thousands of miles. Achieving this monumental task required a brutal trade-off. Millions of people living in established hillside communities exactly like this one were forced to evacuate before the rising water submerged their homes. To understand why a government would erase entire cities and displace its own citizens, we have to look at the existential threat this structure was designed to stop. This is the Yangtze. For thousands of years, it has served as the economic and cultural spine of China. These deep gorges provided water for millions of acres of farmland and created a natural highway for trade. But during the monsoon season, this vital artery routinely morphed into an uncontrollable killer, swelling to breach its banks and submerge entire regions. The historical record is grim. In severe flood years, thousands of people drowned, and millions of acres of crops were wiped out, leaving survivors stranded in makeshift camps like these. The nation faced a physical dilemma. How do you chain a raging body of water that spans nearly 4,000 miles? Managing the Yangtze required engineers to physically relocate mountains and reshape the river's path. Standard dam engineering was useless against the Yangtze. The sheer volume and velocity of the water rushing through these gorges would crush conventional concrete barriers. Planners proposed a single massive barrier, the first of its kind capable of holding back floodwaters while generating hydroelectric power and passing large cargo ships. This diagram illustrates the core problem. To build a solid foundation, you have to pour concrete on dry bedrock. That means you have to completely halt the river's flow. But to stop a river carrying millions of gallons of water per second, you need the massive weight of a finished dam. You can't build the dam without stopping the water, and you can't stop the water without the dam. Before they could pour permanent concrete, the builders had to find a way to bypass this physical paradox. The solution was a phased strategy known as river diversion. Instead of fighting the entire river at once, they tackled it in pieces. They started by dumping rock and earth into the water to build a temporary barrier called a cofferdam, jutting out from the riverbank. This didn't stop the Yangtze. It squeezed the river, forcing the entire violent flow into a narrower secondary channel along the opposite bank. With the water redirected, industrial pumps drained the trapped basin. Right in the middle of the river, engineers had carved out a dry patch of bedrock. By temporarily hijacking the waterway, they finally had the stable staging ground required to start the build. Now the work began on the exposed river floor. To construct the main wall, fleets of towering cranes had to continuously pour tens of millions of cubic meters of concrete, coordinating an endless supply chain of raw materials. But pouring this much concrete introduces a hidden variable: internal heat. As concrete cures, the chemical reaction produces thermal energy. In a block this thick, that heat gets trapped. The temperature difference would cause the dam to crack and shatter from the inside out. Engineers embedded thousands of miles of cooling pipes deep within the wall to chill the concrete as it hardened. While the team managed the external pressure of the river, they simultaneously stabilized the volatile chemical reactions occurring within the cooling concrete. After years of coring, the main structure was complete. It was time to demolish the temporary cofferdams and plug the diversion channels. The massive steel gates were lowered. Behind the concrete wall, the water levels began to rise, subjecting the megastructure to the full pressure of the Yangtze for the first time. The concrete held. As you can see here, the spillways safely throttle millions of gallons of water, dissipating the river's energy exactly as calculated. At last, the logic loop was broken. For the first time in recorded history, the Yangtze River was under human control. Today, the Three Gorges Dam stands as a nearly mile-and-a-half-long fortress of infrastructure. It houses generators pumping out clean electricity and has ended the deadly flood cycle that plagued the valley for centuries. But that control required an irreversible sacrifice: ancient archaeological sites, vast natural ecosystems, and entire cities were deliberately sunk. Millions of displaced citizens will never return to the land their ancestors walked. The 400-mile-long reservoir submerged mountains and valleys, completely erasing the existing natural landscape to create an artificial inland sea. The Three Gorges Dam proves that we possess the capability to bend almost any force of nature to our will, as long as we are prepared to pay the price.